In the book of Genesis, it reads, "And the Lord God formed man of the dust of the ground, and he breathed into his nostrils the breath of life, and man became a living soul." And from the New Testament, the Gospel according to John, Jesus Christ said, "The wind blows where it wishes, and you hear the sound of it, but do not know where it comes from and where it is going. So is everyone who is born of the Spirit." The defining characteristic of a gas is movement. Invisible air molecules are always moving around us. When we feel this movement, we call it wind. As we will see, the experience of flow. Flow is a term that is used when people become so involved in their action that their whole sense of ego disappears and there's only the happening itself. As, for instance, athletes sometimes do, musicians, artists, whatever, when they get so involved in something that they personally just disappear. So the experience of flow and religion have been intimately connected from the earliest times. As we will see, religion is the oldest and most ambitious attempt to create order out of chaos. This is a picture of a small portion of the Earth as taken from the space shuttle. And you can see that the atmosphere is indeed a very thin layer over the surface of the planet. What are these gases that make up the atmosphere? Or what are the properties, I should say? First of all, it's a fluid. I mean, water is also a fluid, but gases are invisible. They have, since they are fluid, they're constantly shifting, floating, unstable, not rigid. They have a tendency, therefore, to assume the shape of whatever container they're put into. Fluidity is also a quality of being graceful or flowing. In the cosmological system that the ancient Sankhyains put together, it is the first manifestation of movement in the cosmology. It's invisible, but not all gases are. I mean, there are other gases, but I'm talking only here today about atmospheric gases. So, okay. They have some further qualities or properties. Compressibility. You can compress them down and you can give them area to expand indefinitely. They will expand into the cosmos if they can get away from the gravity of the Earth. And they diffuse. So they will mix with one another if you have different kinds of gases in a same space. Given the large amounts of space between gas molecules, two or more gases mix easily with one another to form a homogeneous mixture, and this is called diffusion or diffusivity. And then finally, these gases can be both constructive and destructive. Destructive meaning like erosive, as we will see as we go further. Here's another picture of the Earth. The Earth is at the bottom, and you can see that the moon is at the top, and in between is this layer of atmosphere. The Earth's atmosphere is only about 300 miles thick, but most of it is within 10 miles of the surface. The composition of air includes 78% nitrogen, 21% oxygen, less than 1% of argon, and less than 0.04% of carbon dioxide. There are a few trace elements like neon, helium, methane, krypton, and hydrogen, as well as water vapor, of course. But note that carbon dioxide is 0.04%. Now, Elsewhere in the solar system, we have these gas giant planets. Most of the mass of the solar system, aside from the sun itself, is here in these last 4 large planets. And they retain a lot of the original gases of the nebula from which the solar system originally formed. These planets are so massive that their escape velocities are many times that of the Earth, and therefore they retain the light gases such as hydrogen, helium, and methane. Jupiter, of course, is the largest. That's the one on the left-hand side. And it's 11 times the size of the Earth. It has a dense core of rocks and ice, and most of its bulk is made of liquid metallic hydrogen, which creates a magnetic field. The atmosphere consists mostly of hydrogen, helium, ammonia, and methane. Now, the next planet, Saturn, is about 9 times the size of the Earth, and it has a similar composition in terms of its atmosphere as Jupiter does. And then comes Uranus and Neptune, and they also are primarily the same gases. On our rocky planets, this is just to give some idea of the relative size. The sun is up above, and Earth and Venus are about the same size. Mercury is extremely tiny, and Mars is sort of an in-between size. They're primarily made of very dense materials, and most of them are dominated by carbon dioxide, except for the Earth. Large amounts of oxygen in the atmosphere of the Earth are unusual, for oxygen is a very reactive gas and readily combines with metals and other elements. Earth's atmosphere would mark it as a very special planet for any intelligent beings visiting our solar system for the first time. So let's take a look at the layers of the atmosphere. These are sort of arbitrary, but the scientists have decided on these things, these layers. Okay, so the troposphere is the one closest to the Earth's surface. It's 4 to 12 miles thick, and it contains half of the Earth's atmosphere. Nearly all of the water vapor and dust in the atmosphere are in this layer, and that is why clouds are also found there. So then the next one, which is very much larger, is the stratosphere. It goes from 12 to 31 miles above the ground. Ozone is found in this layer, and it heats the atmosphere while also absorbing harmful radiation from the sun. The air here is very dry, and it's about 1,000 times thinner here than at sea level. Because of that, this is where jet aircraft and weather balloons do their flying around. Then the next one is the Mesosphere, and that starts at 31 miles up and extends to 53 miles. And the top of the Mesosphere is the coldest part of Earth's atmosphere, with temperatures averaging about minus 130 degrees F. But then we go to the next level, which is the Thermosphere, which is exactly the opposite. It goes from 56 miles to about 300 miles up, and the temperatures there go up to 2,700 degrees F. So suddenly we go from the coldest to the hottest. In fact, this is where the space shuttles flew and where the International Space Station orbits the Earth. This is also the layer at which the auroras occur. We've talked about auroras when we talked about light. And the top layer is not shown on this picture. It's called the Exosphere. It's so thin that the atmosphere merges into outer space. It's mainly very widely dispersed particles of hydrogen and helium. Now, the thing of it is, the atmospheric scientists don't mention another layer, which exists right not that far from the surface of the Earth. It's at between 1,500 and 3,000 feet only from the surface is the insect superhighway. lots of insects migrate up there, most notably the painted ladies. These butterflies are flying at speeds of up to 30 miles an hour up there. They hitch a ride from the Arctic Circle to sub-Saharan Africa every year. Their 9,000-mile round trip is almost double the length of the famous migrations undertaken by the monarch butterflies in North America. And they do it in just over a week. So they launch themselves up there, stay there for a week, and come down in sub-Saharan Africa. On the opposite journey, over 1 year, up to 6 successive generations of painted ladies migrate northward from Africa, going up, before making that final generation in 1 week or so, as I said, begin the return trip. Now, there's a quote from Richard Fox, who's in the butterfly conservation group, and he says, "The extent of the annual journey undertaken by the painted lady butterfly is astounding. This tiny creature, weighing less than a gram, with a brain the size of a pinhead, and no opportunity to learn from older, experienced individuals, undertakes an epic intercontinental migration in order to find plants for its caterpillars to eat." This is quite amazing. But now I'm going to go back to the planetary scale. Just a couple more things we want to talk about here. This is a diagram of the trade winds. It's called, due to what's called the Coriolis Effect, which is an offshoot of the Earth's rotation. Since the Earth rotates, it causes the air, the moving air masses to curve so that the winds converge toward the low pressure regions along the equator. I don't know if you can see the arrows very well, but they come from the northeast in the northern hemisphere. They go and the southeast in the southern hemisphere. So they kind of go opposite to one another toward the equator. Now, interestingly enough, they know that global warming is weakening the trade winds. In the Pacific, they've been reduced by 3.5% since the 1800s, and they're projected to reduce another 10% by this century's end. And the people who follow these things say this will have a significant effect on food distribution and other trade activities. But, of course, we've taken advantage of trade winds for millennia. This is just cloud formations. We take them all for granted. We don't realize, for example, that trees actually create rain. That is, places where you have large amounts of trees, like the Amazon and other huge forests like that. Scientists have a lot of questions about atmospheric questions. Okay, so for instance, there's this controversy that's been going on for some time. What was the Earth's early atmosphere really like? For a long time, they thought we had a reducing type of atmosphere here as in the other planets. But now, scientists at Rensselaer Polytechnic Institute have proven that the conditions on early Earth were simply not conducive to the formation of a reducing type of atmosphere, but rather to an atmosphere dominated by the more oxygen-rich compounds found within our current atmosphere, including water, carbon dioxide, and sulfur dioxide. These findings rest on the widely held theory that Earth's atmosphere was formed primarily by gases released from volcanic activity at the surface. So there you go. Volcanoes created our atmosphere, trees maintain it, and here we have the power of wind to shape the planet. Many countries, you know, have special names for wind in certain conditions. Like here, we have the Santa Anas, you know. In middle Western Europe, they have what they call the föhn, which means that the wind comes up one side of the mountain where it cools, and then it sheds its moisture as precipitation, and then it warms again as it compresses coming down the other side of the mountain. So the Chinook wind in Alaska is similar to that. Then there's winds that we call zephyr winds, which came from the Greek word, which means a mild, light, and beneficial type of wind, soft, gentle breeze. In Alaska, they have a funny one called the Williwaw, which is a stormy, cold wind that comes down the mountains. In Australia, of course, where they have amazing ways of naming things, they have something called the Brickfielder, which is a summer wind in southeastern Australia that brings hot air from the outback to the cooler regions. It's named either for the red dust that used to spread over Sydney from the local brickworks, or the fact that it turned the soil as hard as bricks. And then there's the famous Mistral wind that blows over the northwestern Mediterranean coast and funnels it through the Rhone Valley up into Middle Europe. Interestingly enough, now we mentioned that carbon dioxide is less than 0.04% of the atmosphere, but there's a whole carbon cycle that happens in the atmosphere. I'm not going to talk about all of the parts of it, but this is a very comprehensive, going from things that are going on in the soil to things that are leaching off into the water, things that are being evaporated into the atmosphere, and then coming back down again as water. And this also includes emissions that humans create, and what the trees do, and what other animals do. You know, animals, particularly cattle, give off methane. So all of this gets cycled around in the earth, and these carbon compounds are interconverted into living tissue by photosynthesis, and then it returns to the atmosphere through respiration. So it just continues around and around. This fundamentally, this just illustrates, as far as I'm concerned, that nothing is separate. Nothing is separate, even on the physical level. So how can it be on the spiritual level? This is just something nice to look at while we transition from sort of earth science to sort of philosophical, religious concepts concerning the wind. First, we'll start with the Yam Bija. Ancient religions and mythologies made no difference between our breathing and the vibrations of the natural world. They recognized our breath as the primary expression of our energy. For the breath has the supremacy to lift or depress our spirit, to circulate energy in and out of the body, and to bring liberation to the oppressed. The wind, the breath, and the spirit, although in English these are three different words, in other languages these ideas all meld together. For one example, in Hebrew, there's only one word, ruach. Now, if I'm not saying that correctly, if anybody knows Hebrew, please correct me. To translate ruach depends upon the context and upon the understanding of the translator. For example, when God blows upon you, that is the wind. When you breathe the wind, that is breath. And when it gets into you, that is spirit. So that same word can mean any of those three things. First comes the wind becomes the breath, and eventually you have spirit. Although in terms of the genesis of these things, I would maintain that spirit comes first. Second example about languages is taken from the Navajo. The word nilichi, translated into English, means wind, air, or sky. But in Navajo philosophy, nilchi represents the supreme creator, an infinite, boundless force that communicates between all elements of the natural world. It is the holy wind that brings movement, energy, sound, and love to all things that have found life in this world. The word for wind in Sanskrit is Vayu. And as we shall see, Vayu is also identified with breath or prana dwelling in the heart. Crucially, Vayu is both a Purushic and a Prakritic energy. That means it may be identified with Atman or soul. It is always active. It makes a sound as it moves, but it is ever viewless and without shape. Therefore, many Eastern philosophies or religions, practices I should say really, say to meditate on the breath and with the breath. It's a very simple exercise. First we have to be without distraction, and then exhale gently, let go, leave the limits of the mind and enlarge your field of awareness. Penetrate through the world with your breath and dissolve the tension that's tangled within the body. Eventually, if you practice this for a while, you may even find that the wind is blowing straight through your body as if it was not there. Now, one master's advice is learn to flow out like a gas without any destination, he says. So, if we do this simple exercise, we may feel that exactly that is happening. Furthermore, in India, they had the depiction of Vayu, the wind deity, and Vayu and Prana are very basically synonymous. The iconographic Vayu is said to have been born from the prana or breath of the Supreme Purusha, and as a son, he is identified with his father in sacred literature, so therefore he represents prana or heart energy himself. And as we've already seen, Vayu is often associated with Vata, the breath. We have Vata dosha in Ayurveda, that is, people who are predominant in Vata dosha, in the air element, as we say, frequently are rather high strung and need to bring in some other elements to help, kind of stabilize them. In India, the 5 energies that circulate through our bodies are called pranas. These are related to the two constituents of Prakriti, or divine nature. So we can use prana in different ways, is what I'm trying to say, as far as the language goes. In these constituents of Prakriti, we have prana, which means energy, and akasha, which is matter. And then in manifestation, the 5 pranas are those that control our inhalation, exhalation, and other activities within the body. And it helps bring in vital substances and carry out destructive substances. But from the point of view of a more spiritual, or I should say maybe less materialistic point of view, the pranas create a cycle involving aspiration and inspiration. Aspiration means to breathe toward the spirit, to ascend, to soar. And inspiration is to draw in, being infilled with spirit, divinely inspired. Now, these same bits of information, as you'll see right in the middle there at the pivot point, is the Yam Bija mantra of this Anahata chakra or center, the heart center. But then that's right in the middle of the entire Kundalini. But this and most Kundalini diagrams that you see are incorrect in one crucial aspect. According to this diagram, it looks like each center is equidistant from the next, but that's not so. In the Kundalini system, these are psychic centers, and the bottom three are grouped very closely together, trapping most people in concerns for their own survival, bodily needs, reproduction, and a mind that cycles continuously only around those things. Therefore, to raise to the first real level of the spirit is a huge distance, if you want to say, to this fourth or pivot point. This is sort of, I would say, tantamount to what the painted ladies do. You have to cover this huge distance first before you can really say you've stepped onto the spiritual path. So that's the largest gap or leap that the aspirant must take in spiritual life. So the leap is from an individual perspective, rife with me and mine, to the inclusive perspective where one feels that all things are related. And this isn't a mental notion at this point. At this point, it's a lived experience. Here in the heart center, the hallmarks are sharing, love, devotion, compassion, selfless service. When you see no differences, then giving is spontaneous and natural. Without crossing this region right here, this pivot point in the middle, it's not possible to achieve full transcendence at all. So truthfully, most of our practices are merely preliminary to awaken this center in us. After that, then the spiritual quest begins in earnest. Now, here is another way to depict the same information, but a little more dynamically. I like this diagram because it sort of indicates to me that once a person has achieved, or whatever you want to call it, I don't know what the word would be actually, but is residing within that anahata, the soul is actually drawn upward to higher centers by the power of yearning that pulls him or her upward to greater and greater universality and finally unity. At this center, when in meditation, one may hear the continuous unstruck sound, after which this chakra is named the anahata. One practical Sankhya master says, the serpent is an innate force operative between two modes of the void, Brahman and Prakriti. It's interesting that he put it in terms of the void. He's not a Buddhist. He's a Hindu. And advice from that same practical spiritual Sankhya master says, one must learn to live in the very moment that shapes and molds Prakriti without trying to escape from it. Now, according to the Sankhya philosophy, which is a forerunner of Vedanta, it is a comprehensive categorization system that recognizes correspondence between the macrocosm that is the universe, and the microcosm that is the human individual. Under this system, vayu corresponds to the sensation of feeling. It's a passive sensation. Our sense of touch is controlled by a huge network of nerve endings and touch receptors in the skin, known as the somatosensory system. By the way, the skin is the largest organ in the body. And this senses cold, heat, smooth, rough, pressure. So there are thermoreceptors, there are mechanoreceptors for the pressure, tickling, itching, pain. The pain receptors are called nocioceptors, vibrations. And there's a directional sense as when the wind strikes the body. It's similar to a bird's feathers. It knows which way the wind is coming from. This is a quick picture of the skin. I'm not going to go into this. It has 30 identifiable parts. Again, it's sort of like the Earth in microcosm. You hear? Okay, like the Earth's atmosphere is very thin, the skin is very thin, but look at all the layers that go into it and all the different parts of it. And it's also responsible for thermoregulation, keeping you warm enough, but but also keeping the heat in sufficiently so that you don't get too cold. Now, I'm still continuing here with the correspondence between wind and our sensory apparatus. This is the human brain, and the two parts we want to look at are the motor cortex and the sensory cortex. They work together in the sense that as you sense things, you respond to it. You respond automatically. So, if there's a nice incense or something like that, you want to bring it closer. So you're both moving and sensing at the same time. So there's a feedback loop between these. This is a picture of the same two on the left, sensory on the right, motor parts of the brain. But now they've turned it into a mini human, showing, relatively speaking, how much of that brain portion is devoted to certain sensory parts of the body. So you'll see that on the left-hand side, the face, particularly the around the mouth, and the hands are very huge. But then look at the motor one on the other side. The hands are huge. Okay, so this is where we get. Usually we think we get information, like through our eyes or whatever. But look at how big. Look at how big the hands are. It's amazing. Hence, we tend to focus mentally on utility. What can we do with the wind in this case? So I'm going to quickly run through a bunch of things here. Ancient weapons. We go from the boomerang and the bow and arrow as some of the first ones. Then we have windmills to pump water, to grind grain, and finally, the most recent one at the bottom there, to generate electricity. Of course, we can only see the effects. We don't see the wind itself. It took thousands of years to reach this level of sophistication in sailing vessels. The first were merely simple sails suspended from a single mast, and it had limited flexibility. Then finally, we began to explore a little bit more in the 19th century, particularly, with hot air balloons, not only for exploration, but for entertainment also. I mean, can you imagine people going up in a balloon, and a lot of times they were tethered. They weren't just, floating off, just to get a different perspective, a perspective that they never had before. They didn't have skyscrapers. They couldn't stand on top of the Empire State Building and look down on New York City. No. So it literally blew their minds to get up that high. We also had the hot air balloon the weather balloon is on the right-hand side. We still use these all the time to detect wind direction and speed and things like that. And then there's the dirigible, and that's, I understand, having a comeback. One of these days we're going to see more of these in use because they've found a better way to propel them and float them up there. Then we have gliders. Now, gliders go back as far as, at least in theory, as far as the ancient Greeks, because there's the story of Icarus and Daedalus and how they manufactured wings and tried to take off into the atmosphere. They make use of the up currents That is, the hot air rising to keep them up there provides lift. And then for airplanes, we've had airplanes for only about 100, slightly over 100 years. The wing curvature is shown on the top. This is from a wind tunnel showing how it helps to lift the airplane, showing the gases flowing around it. It's similar to the wake of geese when they fly in formation. And then modern day jets. This is, of course, can attain much greater speeds and altitude than propeller-driven aircraft. This shows how, this is a wind tunnel type of picture also, showing how the wind curves around and then actually gives the plane a kick from the back. Again, this is similar to the way that geese in formation do it. We also use the wind for pleasurable and religious purposes. Okay, so for instance, we can have fun with kites. We have prayer flags. We blow bubbles. We have these nifty little, I can remember playing with for very small children, playing with those little whirligig things when you're a kid. And then, of course, we have all kinds of wind instruments. So auditorially, we can play with the wind. But the wind has its own agenda. So there's this wind that comes off from the north, that's experienced by sailors, fishermen, trappers, outdoorsmen. Whips out of the northeast across the Great Lakes from Canada, brings sudden shift in temperatures and frosty effect. Here's another thing about how the wind has its own agenda. Okay. So it forms what we call dissipative structures. I mean, it looks like there's a real structure there, but it isn't really. It's completely composed of dust and or water spouts. In Australia, there's one, a whirling wind that they call the willy willy. It raises small columns of dirt or dust devils from the ground. And then, of course, there's always the tornado, which are getting to be, now we hear about supercell tornadoes, which I don't ever remember that when I was a kid. This is a new phenomenon. So now they're rating tornadoes like they rate hurricanes in terms of the strength and potential destructiveness. Then we have, this is a haboob, a strong wind or a sandstorm, dust storm. The term originated in the northern and central Sudan, particularly around Khartoum, where the average number of them is about 24 a year. And it comes from the Arabic word hab, which means wind. Here's a haboob coming toward Phoenix, Arizona. This is a relatively new phenomenon in the US, although I'm sure during the Dust Bowl period, they probably had that back in the 1930s. All over the world, our air is in trouble. These are the pictures of air-polluted cities. Ours in LA isn't as visible as it used to be, but it's still there. It's a different kind of air pollution. There's a rise of airborne illnesses like asthma, and it's the very young and the very old are vulnerable to this. There's a decrease in life expectancy, living along freeways, near chemical factories, etc. In Austria, which you would think, I mean, what could be more pristine than Austria? There's the Alps, and it's so gorgeous in the middle of Europe. It doesn't have all these, negative influences in it. Well, I'm here to tell you, in Austria, 10% of the children now have asthma. We're already paying for water, so will we be paying for fresh air next? How have the greenhouse gases increased? This graph only shows carbon dioxide. in millions of metric tons per year. But there's also methane, etc., other ones. And I don't want to, belabor this, but this shows the different kinds of gases that are being spewed out by human activity. Carbon dioxide, primarily from fossil fuels, but it can also come from direct human-induced impacts on forestry and other land uses. Likewise, however, land can also sequester carbon. So it has the capability of reducing the amount of carbon dioxide if we use the proper techniques for that. Methane comes from agricultural activities. And waste management, energy use, melting permafrost, and biomass burning. Nitrous oxide, which is kind of the smallish 6% thing up near the top, comes from fertilizer use primarily. And then the fluorinated gases, which are entirely man-made come from industrial processes, refrigeration, and a use of a variety of consumer products that contribute to the emissions of fluorocarbons. Now, if you exclude refrigeration as a source, this shows by, I've already mentioned these here, but it's interesting to note, electricity accounts for 25%, agriculture is right behind it, industry is 21%, so slightly less, and then comes transportation, and buildings, 6%. Others, a whole bunch of smaller sources all lumped together for purposes of reporting. Now, which countries? Now, this I found rather interesting because we always hear about how bad the U.S. is, but look at this. China emits twice as much as the U.S., and then everything comes down from there. The EU, 9%, India, 7%, Russia, 5%, Japan, 4%, and then the whole rest of the world accounts for the same amount as China does. It seems like the rest, everybody has a right to pollute. I mean, everybody, each of us individually do also. You can go out and start a fire anywhere. And the homeless people do that on a regular basis out here. Just, hey. Okay, so now, here's what all the hullabaloo is about in terms of, people talking about carbon dioxide. And this graph goes from 1960, which is not all that long ago, to just past 2015. And it shows we've gone from about 315 parts per million to 411. Does anybody know why this looks like a zigzag line? Can anybody say that? Seasonal, yes. It's seasonal because when the deciduous trees lose their leaves in the winter, the carbon dioxide goes up. And then when they put their leaves back in and they start to photosynthesize, it goes back down again. It took the people, the investigators, quite a long time to figure out why they had this zigzag line. And then they realized this is the earth breathing. This is how it works. But in actuality, the earth is gasping for breath. 350.org is devoted to putting the world on 100% renewable energy. They're not the only one. There are many organizations. Their goal is simple: to keep global warming below 1.5% Celsius. Warming below that, I should say. Coal and oil and our gas needs to stay in the ground. But it's very, very difficult to accomplish this politically, although the technology is readily available. Everybody agrees with that. Now, more importantly than how we use the air is how the air uses us. The Ruach of God moves over the world and begins the creation of the landscape. As stated before, Ruach is the Hebrew word for air in motion, or rather wind, spirit, breath. And Elohim can mean great or God. Therefore, Ruach Elohim may be translated as the breath of God.